In this video, we're going to look at how to calculate the key statistics for the binomial distribution. The good news is that these statistics are the same for all different kinds of probability. We still only care about the mean, the variance, and the standard deviation. The only thing that differs is how they're calculated. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The mean of a binomial distribution is calculated quite simply as just n multiplied by p, where n is the number of trials and p is the baseline probability of success. That's it. So, if you can identify that your probability is binomial rather than just discrete, it can save you a lot of time rather than having to calculate it as if it were just some generic discrete probability. So, here's an example. There are 5 white and 3 black balls in a jar. We are just going to select one from the jar, note its color, put it back. And we're going to repeat that 3 times. This is an example of a binomial distribution because it meets the 3 criteria of a binomial distribution. Firstly is that there's 2 outcomes. You either get a white ball or a black ball. Second is that each trial is independent. This is because the experiment is effectively reset every single trial because we're putting the ball back. And lastly is that the probabilities don't change from trial to trial. Again, this is because we're putting the ball back. Now that we know it's a binomial distribution, the mean is just going to be calculated by n multiplied by p. We know that n equals 3, since that's the number of balls that we're selecting, and we know that our probability of success p is just 5 over 8, since the probability of getting a white ball is 5 over 8. So all we're going to do is multiply to get the mean. The variance is also fairly straightforward to calculate. It's just np multiplied by 1 minus p. Another way you can write that is mu multiplied by 1 minus p, where mu is the Greek letter for the mean. So if we want to calculate the variance for this distribution, then all we're going to do is slot in the n and p values that we figured out before into the new equation and simplify for the variance. And, like always, the standard deviation is just going to be the square root of the variance. So the most common way of finding the standard deviation is just to first find the variance, np multiplied by 1 minus p, and then square root that result. Sometimes, instead of being asked to calculate the statistics, you'll actually be given the statistics and then be asked to figure out what n and p must have been given those values for the statistics. This is also going to be solved by subbing into their equivalent equations. We're told that the mean is 4, hence n multiplied by p must be 4. We're told that the variance is 2, hence np multiplied by 1 minus p must be 2. Now, if you want, you can solve this simultaneously. You've got 2 equations and 2 unknowns. That will work perfectly fine. But you can do it ever so slightly faster if you just replace the np from the variance equation with 4, since we know that's what it equals. That already gives you an equation with 1 unknown in it, and you just rearrange to get p equals a half. From there, you sub that p value back into the mean equation, n times p, and you're going to get n equals 8 from that. The key takeaway here is that as long as you know the statistics, the mean, the variance, or the standard deviation, you can actually back solve to get what n and p must have been. Confidence intervals are always calculated using the same generic formula. They're always going to be centered at the mean, and they're always going to be spread out by a certain number of standard deviations, depending on how confident your interval is. The main confidence interval you're going to be required to calculate is the 95% confidence interval, and that's going to require you to calculate the mean and then plus or minus 2 standard deviations either side of the mean. For example, we're told that 80% of students attend a public school, and we're grabbing a sample of 400 students to see if we can represent that. If you want to calculate a 95% confidence interval of this group, then we need to know the mean of the group as well as the standard deviation of the group. The mean is calculated by n multiplied by p, where n is 400, since that's the number of total students, and p is 0.8, because that's the probability of attending a public school. To get the standard deviation, we need to first calculate the variance and then square root that result. The variance is going to be calculated by np multiplied by 1 minus p, since again this is binomial, and then we're just going to square root that result to get back to the standard deviation. We now have all of the building blocks required to calculate the confidence interval. The upper bound is going to be given by the mean plus 2 standard deviations, and the lower bound is going to be calculated by the mean minus 2 standard deviations. After simplifying, we get a result of 304 to 336. What this means is that we're 95% confident that the number of students in this sample that attend a public school is going to be somewhere between 336 and 304. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.